All right, guys. These should be the last couple of problems we do with the exponents, and then we will just be working with quadratics. Okay, so let's see. If I take this top one, I'm going to get rid of the negative exponent first. Okay, so I would get 1 over 1/12 to the 5/4 power. Okay, so let's see. That is 1 over the 5th power of the 4th root, okay, of 1/12, like that. Okay, so let's see. I know what I would do here. I'd say, okay, well, that means I have 5 factors of the 4th root of 1/12, so I can pull 4 of them away. The 4th root of 1/12 to the 4th. Now, the reason I do that is because the 4th power of the 4th root of 1/12 is just 1/12. But I still have one more, the 4th root of 1/12, like that. Okay, so let's see, 1 over, well, the 4th power of the 4th root of 1/12 would be 112. And then I need to do something with this 4th root of 1/12. All right, now 1/12 is not a perfect 4th power. Okay, so we take a look at, okay, well, what factor is? Well, let's see, we've got 1 to the 4th is 1, which doesn't help. We've got 2 to the 4th is 16, which might help. We have 3 to the 4th is 81. I don't think it'll help. And we have 4 to the 4th, which is 256, so we're already too big. So it has something to do here. And I think it's a 16. So if we take 1/12 and divide by 16, what do we get? 7. Okay. So let's see. This is 1 over 112 times the 4th root of 16 times 7. Let's make sure we got that. Yep. Okay, so let's see. The 4th root of 16 is 2. So we'd have 1 over 112 times 2 times the 4th root of 7. Okay. So let's see, the 2 times 112, that'd give us 224, right? Yep. So we get 1 over 224 times the 4th root of 7. And now I have to rationalize. So I got to multiply by the 4th root and by the 4th root, like that. Now, I have one factor of 7. If I had 4 of them, it'd be the 4th root of 7 to the 4th, and that's just 7. So I have 1, so I need 3 more. So I'd have to multiply by the 4th root of 7 cubed, 4th root of 7 cubed, like that. Okay, so I get the 4th root of 7 cubed, and that's 7 times 7 times 7, so we go 7 cubed, that's 343. All over 224 times, well, the 4th root of 7 times the 4th root of 7 cubed would give me the 4th root of 7 to the 4th, and it's rationalized, that's 7. So all I got to do is just multiply the 224 times the 7, and I'm done. So we get the 4th root of 343 all over, let's see, 224 times 7, 224 times 7, 798. Okay, and we're done with that guy. So let's go to the next one. Okay, so this guy is all finished. Okay, let's see what we got going on here. Same type of problem. I'm going to rewrite that as 1 over 160 to the 6/5 power, which is the same as 1 over the 6th power of the 5th root of 160. And so if I had the fifth power of the fifth root of 160, I just get 160. So I'm going to pull that apart. So I get 1 over, let's see, we would have the fifth power times another one, because we have to have a total of 6 of those. Okay, so I'd get the fifth power of 160 times the fifth power of 160. Okay, so I got 5 of them here, I got 1 of them there for a total of 6. Okay, so the fifth power of the fifth root of 160 is just 160. So I get 1 over 160 times the fifth root of 160. Okay, and then we have to look at what factor of 160 is a perfect fifth power. So I got 1 to the fifth is 1, doesn't help. 2 to the fifth is 32. 3 to the fifth, and I'm pretty sure that's 243. 3 to the fifth, 243. So notice we're already too big. This guy never helps. That guy's too big, so our only choice, our only chance, I should say, is if 32 is a factor of 160, so we divide. Okay, so we go 160 divided by 32, sorry, I put 35, 32, and we get 5. It's 5 times 32. Okay, so let's see, we have 1 over the 160, and then we have the fifth root. 160 is 32 times 5, right there. Okay, so 1 over 160. Well, the fifth root of 32 is 2, and then I am left with the fifth root of 5, like that. Okay, so I got 1 over 160 times 2 is 320 times the fifth root of 5. All right, now I know I got to rationalize, so I got to multiply by the fifth root of something and the fifth root of something. Okay, so if I had 5 factors of 5 underneath, I'd have the fifth root of 5 to the fifth, which is just 5. Okay, so I have 1, and I need 4 more for a total of 5. Okay, so here we go. So I go the fifth root of 5 to the fourth. 5 to the fourth is 625. All over 320 times, well, if I have 1 factor of 5 and 4 more, I have a total of 5 underneath. Okay, so I would have the fifth root of 5 to the fifth. Well, the fifth root of 5 to the fifth is just 5. So I get the fifth root of 625 up above, all over 320, 320, not 32, times 5. And then I just multiply. So the fifth root of 625 all over, let me see, I think that's 1600, but let me check. 5 times 320, 1600. And we're done. Okay. Let's see. We're graphing those guys using the critical points. Okay. All right, which we covered in class. I always start with the axis of symmetry. Axis of symmetry. So we know that happens at x equals the opposite of b over 2a. So that's going to happen at the opposite of -10 all over 2 times a, which is 1. Okay, so my axis of symmetry is the vertical line, 10 over 2, which is x equals 5. Okay, so there's my axis of symmetry right there. Okay, now I'm going to do my vertex. Okay, so remember, your vertex has to be on this vertical line. Okay, so we know all of the x coordinates are 5 there. Okay, so to find my y coordinate, I have to go f of 5. Okay, so I have 5 squared minus 10 times 5, okay, plus 7. Okay, so I get 25 minus 50 plus 7, which gives me negative 25, plus 7, which gives me, what, negative 18? Yeah, negative 18, right there. Okay. Then I'm going to look for my x-intercepts. Now remember, your x-intercepts happen on the x-axis when y is 0. So it happens when f of x is 0, so we set this guy equal to 0 and solve. Okay, so I get x squared minus 10x plus 7 equals 0. And then I factor that. That would be, wait a minute, that's not going to factor. That's not going to factor at all. Okay, so we've got to go to the quadratic formula. Okay, so let's see. X would be the opposite of negative 10 plus or minus the square root of negative 10 squared minus 4 times a, which is 1, times c, which is 7, all over 2 times a. That'd be 2 times 1 or 2. Okay, so I'm going to get positive 10 plus or minus the square root of, let's see, that would be 100 minus 28 all over 2. Okay, so I get 10 plus or minus the square root of 72 all over 2. Radical 72 is not in simplest radical form. So let's see, I get 10 plus or minus, let's see, that would be, what, 9 times 8. Oh, how about 36 times 2? Okay, so the square root of 36 is 6, so I get 10 plus or minus 6 radical 2 all over 2, which means I can divide everything by 2 there. So 2 divided by 2 becomes a 1, 10 divided by 2 becomes a 5, 6 divided by 2 becomes a 3. So I get 5 plus or minus 3 radical 2. Okay, so my x-intercepts end up being 5 plus 3 radical 2 and 0, and 5 minus 3 radical 2 and 0. There you go. Now, we are probably going to have to punch those into the calculator to get an idea, you know, what number is that? What number is that? Okay, so I will do that. So let's see, 5 plus 3 radical 2, 5 plus 3 times second square root of 2. That's roughly about 9.42, and this is roughly about 9.42 and 0. And then let's see if I go 5 minus 3 radical 2. 5 minus 3 times second square root of 2. I get about 0.76, about 0.76 and 0. And that'll help me with the graphing portion of it, okay? All right, and remember, this graph is not going to be perfect. It's just a sketch, okay? So let's see, okay. All right, here. And we have here. So I have my x and y, or x and f of x. It doesn't make any difference. Okay, so I have my axis of symmetry at x equal 5. Okay, so let's see, we'll put that guy about right here. This is my x equals 5. Okay, I have one x coordinate, okay, here, and one x coordinate here, so that guy is basically past there. And remember, those x intercepts, okay, remember the axis of symmetry would be right in the middle. Okay, so let's see, I have this guy and I have this guy. And let's see, I can give exact answers now. Okay, so this is at 5 plus 3 radical 2 and 0. And this guy is at 5 minus 3 radical 2 and 0. Okay, and so I just need these to help me out with my graphing. And then we have this vertex at 5, -18, so that guy's way down here. So maybe about right there at 5 and -18. Okay, so let's see. Okay, let's see. It's my right half, which looks okay. Let's see if I can do it on the left half too. Okay, so let's see. Okay, yeah, it looks okay. Not great, but it's okay. All right, let's see. Got another one of these guys. Okay, so again, let's start with our axis of symmetry. So it'd be x equals the opposite of b over 2a. So I get the opposite of 9 over 2 times a, which is 2, so 2 times 2. So I'm going to get x equals -9/4. Okay, so there's my axis of symmetry. Okay, then we do our vertex. All right, now we know the vertex is on this vertical line, so I know that the x-coordinate has to be -9/4. Okay, I've got to find my y-coordinate, so I've got to go f of -9/4. Okay, so that's 2 times -9/4 squared plus 9 times -9/4 minus 3. Okay, so let's see, I get 2. When I square -9/4, I get 81/16. Right here, when I multiply, I'm going to get a -81/4 and then a minus 3. So let's see, I cancel the 2 with a 2 here, so that becomes 81/8. So I get 81/8 minus 81/4 minus 3. And let's see, we get that one. So we have 81/8 minus 81/4 minus 3. So I'm getting -13 1/8, which would be the same as -105/8. So it's just a matter of how you want to do it. I could write that as -105/8. Okay, and if I wanted to write, rather than improper fractions, if I wanted to write mixed numbers, I'd have a -2 1/4 and a -13 1/8, like that. Okay, so either way it's good. Okay, now we need our x-intercepts. Okay, so remember that's going to happen on the x-axis when y is 0, so my f of x will be 0, so I set that equal to 0 and go about my business. So 2x squared plus 9x minus 3 equals 0. And I don't know whether that factors or not. I got to take a look at it. So let's see. Okay, here, here, here. So it'd have to be 2x and x. And -3 would have to be a 3 and a 1. One's positive, one's negative. But with that 9, I'm thinking the 3 would have to go here, which means the 1 would go there, which means this would have to be positive, that would have to be negative. And notice we look at our O's and I's. 2x times 3 is 6x. -1 times x, -x. So notice it doesn't work. And if I switch this guy over here and this guy over here, it won't work either. So I've got to go to the quadratic formula. Okay, so let's see. So our x's equal the opposite of b, so that'd be -9, plus or minus the square root of b squared, so that'd be 9 squared minus 4 times a, which is 2, times c, which is -3, and that's all over 2 times a, so I'd have 2 times 2, which is 4. Okay, so let's see, I get -9 plus or minus the square root of, that would be 81, and then notice the negatives cancel each other out, so that's plus. 4 times 2 is 8, 8 times 3 is 24. All over 4, which gives me -9 plus or minus the square root of 105 all over 4. And I want to say I think the square root of 105 is in simplest radical form. 105 divided by 5 is 21. So you get 5 times 7 times 3, no factors. Okay, so that's in simplest radical form right there. So our two x-intercepts would be negative 9 plus radical 105 over 4 and 0. Okay, and our other one would be negative 9 minus radical 105 over 4 and 0. Okay, now to help us with the graphing part of it, I'm going to punch those in and round them off. So let's see, negative 9 plus second square root 105, hit enter, and then divide by 4. So that's roughly about 0.31 and 0. And then the other guy, let's see, we have negative 9 minus the second square root 105, and then divide by 4. That's roughly about negative 0.481 and 0. Okay, so let's see what we got. All right. Okay, so I have an axis of symmetry at negative 9/4, which is negative 2 1/4. Okay, so maybe that guy is about right here. So x equals negative 9/4. Okay, and let's see. I have something right here that's barely passed right there. And then let's see, negative, so that guy would be over here. Okay, so this guy right here would be this guy. Negative 9 plus radical 105 over 4 and 0. And this guy right here would be this guy. Negative 9 minus radical 105 over 4 and 0. Okay, so our axis of symmetry should be right in the middle of these guys. And then notice we're down here somewhere. Okay, and this is our, either this guy or this guy. It doesn't make any difference which one you use. It's just a matter of how you want to write it. So I'm going to write it as negative 9/4 because I'm using x equal negative 9/4 for my axis of symmetry. And negative 105 over 8. Okay, and then we have something that looks like this. Okay, not too bad. And let's see this guy. Oh, that one's bad. Ooh, look how they don't look like they're mirror images of each other. Yeah, that one's bad. Okay, so let's wrap up this video and then we'll start a new one.